The film to familiarize engineers with some differences between the color television receiver and a mono receiver from the point of view of adjustment and installation. Viewers should not attempt to make any adjustments to the receiver other than by means of the ordinary controls provided. The film will be in 5 main parts: receiving the signal, preliminary checks and adjustments, convergence, reference white and grayscale, and general instructions to viewers, particularly throughout normal trade test periods. Part 1 deals with signal reception. No matter how good a receiver may be, it cannot show a good picture unless it is provided with a good signal. This usually demands an efficient outside aerial with a low-loss coaxial. A loft aerial clear of metal objects may, however, be satisfactory in strong signal areas. Room aerials and set-top aerials will rarely give satisfactory results and may result in objectionable ghosting effects dependent on the position of people within the room. Short-term reflections can also give rise to unbalance between the luminance and chrominance signals. Repositioning the aerial may give an improvement, and the rigid mounting of the aerial is also important. Aerial systems lead us into the effects of an insufficient signal. A noisy picture can be symptomatic of either a poor aerial installation or an area of low field strength. From insufficient signal, we move to incorrect bandwidth. It is important that the response at the color subcarrier frequency is similar to that at the vision carrier frequency. If the aerial bandwidth is incorrect, one or other of these will probably be low. An aerial chosen for the correct group of channels in your area should be used. From signal reception outlined in Part 1, we move to preliminary checks and adjustments in Part 2. The procedure outlined in this and the following parts may be useful as a general guide. First, routine checks such as the setting of the mains tapping, proper scan amplitudes, linearity, centering and focus should be made. Any subsequent alterations to the shape of the basic black and white picture are liable to have a detrimental effect on the quality of convergence. A color picture tube is very sensitive to magnetic effects, due either to local or the Earth's magnetic field, and it may easily become permanently magnetized. Adjustments should be made with the receiver in the position in which it is intended to be used. This effect can most easily be seen when displaying a single color raster. A magnetized tube is incapable of giving a proper color picture, and it is necessary, therefore, to demagnetize it. This procedure is called degaussing, and it's expected that all color television sets will be fitted with automatic circuits to degauss the screen every time the receiver is switched on. The color patches on a magnetized tube can be confused with purity misadjustment, so the tube must be degaussed before any other adjustments are made. Workshops should be equipped with their own degaussing coils to deal with rare cases of severe magnetization. To adjust for purity errors, refer to the manufacturer's instructions and follow them exactly. The adjustment should be made in a darkened room. This will usually involve the adjustment of the purity magnets and the yoke assembly mounted on the neck of the tube. Then checks should be made separately on the green and blue rasters and a final check with a white raster. Part 3 takes us through the 2 sequences of convergence adjustment, static and dynamic. The shadow mask color picture tube constructs the complete color picture out of 3 separate pictures, one in red, one in green and one in blue. it is essential that these three pictures register as accurately as possible. The registration can never be quite perfect, but it is possible to get results that do not show serious color fringing at normal viewing distances. This registration of the three color pictures is called convergence. Convergence involves rather complicated processes, and any adjustments to this part of the circuit should be carried out exactly as instructed by the manufacturer. Shortcuts will lead to unsatisfactory results. Test card F can be used for checking, but for adjusting convergence, it is better to use a grid from an electronic pattern generator which produces a white grid on a black background, sometimes called a crosshatch generator. Convergence is adjusted in two sequences, static and dynamic. For the purpose of this film, the effect of lack of convergence has been exaggerated. In practice, the misregistration is likely to be small, and in many cases, no adjustment may be needed. The general outline of the procedure is as follows. For static convergence, switch off the blue gun, and using the red and green static convergence controls, adjust the red and green to give a yellow pattern at the center of the screen. Then switch the blue gun on, and using the blue static and lateral convergence controls, adjust for white at the center. Do not aim with the static controls for convergence other than in the central area. Dynamic convergence is the adjustment to give registration over the rest of the screen. This is effected by passing a combination of parabolic and sawtooth field rate. As most color sets will be dual standard, it will be necessary to carry out some adjustment on both. Different techniques will be employed by different manufacturers, and their instructions must be precisely followed. The next section concerns itself with reference white and with grayscale. It will have already been gathered from this film that on a color television screen, white is obtained by a suitable mixture of light from the red, green, and blue pictures. If the proportions of this mixture are incorrect, there will be an overall cast of the predominant color or combination of colors. For example, if the blue gun is weak, the picture will appear too yellow. If green is weak, it will be magenta. And if red is weak, it will be a bluey green called cyan. If any of the three primary colors are too strong, then the picture will appear shaded towards that color. For a properly balanced color picture, it is important that the receiver is adjusted to give the correct white. This white is difficult to show on film, but it has been standardized as illuminant C. This is a warmer white than on monochrome receivers, and the white must be correct not only at full brightness, but also at all levels throughout the gray scale. If this is not done, the picture of a bus, for example, which appears bright red in sunlight, would change color when the bus moved into the shade. This is gray tracking, and because of the importance of getting the right adjustment near black level, it cannot be carried out in a lighted room. If subdued lighting cannot be achieved due to strong daylight, it is best carried out under workshop conditions prior to the installation of the receiver. To obtain good grayscale tracking, it is necessary to get the characteristics of the three guns to match each other near black level at peak white and at every point between these levels. Manufacturer's instructions should again be followed exactly, a typical sequence being to align the cutoff points for the three guns, then by proportioning the drive voltages to obtain illuminant C at peak white and as far as possible over the whole gray scale. The last part of this film on color television receivers deals with some general instructions you can give to viewers. Before leaving the installation, it will be necessary for you to show the viewer how to operate the receiver, especially the tuning, if this is of the continuous type. The viewer should be advised on the best subdued lighting conditions and the best seat positioning for viewing. The color control setting is likely to be very much a matter for individual taste. Finally, it should be stressed that the setting of the hidden controls is a complicated matter, and that no adjustments of these should be attempted by the viewer. To sum up, the aspects which need to be checked and occasionally adjusted when a color television receiver is installed are provision of a good signal, standard preliminary checks, screen demagnetization, color purity, convergence, reference white and grayscale, and finally, the viewers should be shown how to get the best results from their new color television receiver.